Hello and welcome to Sourav sir classes. Today we'll solve MSTAT 2022 ISI examination questions. So let's get started with the first question. It says that consider a sequence RK, k greater than equal to 1 of natural numbers. So we have of rational numbers lying in the interval 0 1. Further, assuming that that RK converges to uh, to an irrational number as k tends to infinity. Suppose that RK equal to mk by nk for all k greater than equals to 1, where mk and nk are positive integers with no common divisor, so that the integers nk k greater than equal to 1 is not bounded. So with okay, so we solved the first question, which so we have sequences of we have sequence of rational number. So RK number 1, RK is a sequence of rational number. Then suppose nk k greater than equals to 1 is bounded. On the contrary, we assume that it is bounded on the contrary, and will reach to a contradiction. So suppose this is bounded, and if we have a sequence of real number bounded, then we'll have a convergent subsequence. So this has a convergent subsequence. Say so there exists alpha k in n such that n alpha k is convergent. Now you notice that these are sequences of with value from natural numbers. So and it is convergent. So it has to be eventually constant. So n alpha k is eventually constant. So that means n alpha k is equal to some n naught after for all k greater than equal to uh, alpha k greater than equal to k naught for some k naught for some k naught. Now, so being said that, then the limit k tends to infinity n alpha k, this is equal to n naught. So now we'll go back to our main sequence. So that is r alpha k, r alpha k. So this also converts to so suppose r alpha converges to a so rk converges to Suppose RK converges to some x is irrational, 0, 1, minus q, so it's a irrational number. Now then R alpha k, because it is convergent, its all subsequents will also converge to the same limit, so it converges to x again. Now R alpha k is equal to m alpha k by n alpha k. Now we know n alpha k, where does it converge? So we can see, so that implies m alpha k equal to r alpha k times n alpha k. This converges to x times n naught. So that means that is m alpha k is a convergent sequence. So it is a convergent sequence. Now m alpha k, since it is a convergent sequence and its value is inside this your natural number, and so m alpha k's are in natural numbers. So this has to be again eventually constant. So that means there exists a k1 such that for all alpha k greater than equal to k1, this m alpha k equal to m naught for some m naught, since it is convergent. So that means now uniqueness of limit takes place. Uniqueness of the limit says that this x times uh, n naught is equal to m naught. So that means x equal to m naught by m n naught, and then it is inside q, which is a contradiction. So the sequence, n k in n is unbounded. It cannot be bounded. So that's the answer.